The 2020 National Electrical Code NEC introduces a new requirement for conduit sizing in certain classified locations. Specifically, NEC 502.100 addresses raceways in Class 1, Division 1, and 2 locations. If a raceway in these classified areas contains 4 or more current carrying conductors, the code mandates that the raceway must have an internal cross-sectional area, or CSA, that is at least 20% larger than the sum of the cross-sectional areas of all the conductors it contains. To fully understand this requirement, it is essential to clarify several key terms. Firstly, a classified location refers to an area where flammable gases, vapors, or dust may be present in the air in sufficient quantities to produce explosive or ignitable mixtures. These locations are classified based on the type of hazardous material present and the likelihood of its presence. Secondly, a raceway is any channel designed and used expressly for holding wires, cables, or busbars. Raceways can be metallic or non-metallic, and examples include conduits, electrical metallic tubing, or IMT, and cable trays. Thirdly, the term current carrying conductor denotes a conductor that normally carries electric current under usual operating conditions. Neutral conductors that carry only the unbalanced current from other conductors, as well as equipment grounding conductors, are generally not considered current carrying conductors for the purposes of this code section. With these definitions in mind, let us examine the rationale behind this code requirement. In classified locations, the risk of explosion or fire is inherently higher due to the potential presence of flammable materials. The primary reason for mandating larger conduit sizes is to enhance safety by providing additional space for heat dissipation. When multiple current-carrying conductors are grouped together within a confined space, such as a conduit, they generate heat due to the electrical resistance of the conductors. The amount of heat generated is proportional to the square of the current flowing through the conductors. If the heat is not adequately dissipated, the temperature within the conduit can rise significantly. Excessive temperatures can have several detrimental effects. 1. They can degrade the insulation of the conductors, leading to short circuits, ground faults, and potentially fires. 2. They can increase the resistance of the conductors, reducing the efficiency of the electrical system and causing voltage drops. 3. In classified locations, high temperatures can create a risk of ignition, especially if flammable gases or vapors are present. The larger conduit size mandated by NEC 502.100 helps to mitigate these risks by providing more surface area for heat to radiate away from the conductors. The increased airspace within the conduit also promotes better ventilation and convection cooling. By keeping the conductors cooler, the risk of insulation degradation, short circuits, and ignition is significantly reduced. Another important consideration is the potential for arcing or sparking within the conduit. Arcing occurs when electricity jumps across a gap between conductors or between a conductor and ground. Sparking is a similar phenomenon involving the sudden release of electrical energy. Both arcing and sparking can generate extremely high temperatures, sufficient to ignite flammable materials. In classified locations, any arcing or sparking event can have catastrophic consequences. The larger conduit size helps to reduce the risk of arcing and sparking by providing more physical separation between conductors. This reduces the likelihood of accidental contact or insulation breakdown. Furthermore, the increased space within the conduit allows for better installation practices. Electricians have more room to properly terminate conductors, ensure tight connections, and avoid damaging the insulation. These factors contribute to a more reliable and safer electrical system. It is important to note that the 20% increase in cross-sectional area is a minimum requirement. In some cases, it may be necessary to use even larger conduits to ensure adequate heat dissipation and safety. Factors such as the ambient temperature, the type of conductors used, and the amount of current flowing through the conductors should all be considered when determining the appropriate conduit size. In addition to the size of the conduit, the type of conduit used is also an important consideration in classified locations. Metal conduits, such as rigid metal conduit or RMC, and intermediate metal conduit or IMC, are generally preferred over non-metallic conduits. Metal conduits provide better mechanical protection for the conductors, and they also serve as a grounding path which can help to reduce the risk of electrical shock. Non-metallic conduits, such as PVC conduit, may be used in some classified locations, but they must be installed in accordance with specific requirements outlined in the NEC. These requirements typically include the use of grounding conductors and special fittings to ensure a continuous grounding path. When selecting conduit fittings, it is essential to use fittings that are specifically listed for use in classified locations. These fittings are designed to prevent the ingress of flammable gases, vapors, or dusts. They typically have threaded connections and explosion-proof seals to maintain the integrity of the enclosure. Proper installation practices are also crucial for ensuring the safety of electrical systems in classified locations. Electricians working in these areas must be properly trained and familiar with the specific requirements of the NEC. They must also use appropriate tools and equipment to avoid damaging the conductors or conduit. Some additional best practices to keep in mind when working with conduits in classified locations are: firstly, always consult the NEC and any other applicable codes and standards before beginning any electrical work. Secondly, use only listed and approved materials and equipment. Thirdly, ensure that all conduits and fittings are properly installed and sealed. Fourthly, inspect the installation carefully before energizing the circuit. Fifthly, document the installation thoroughly, including conduit sizes, conductor types, and fitting locations. In summary, the 2020 NEC requirement for larger conduit sizing in Class 1, Division 1 and 2 locations is an important safety measure designed to reduce the risk of explosion and fire. By providing additional space for heat dissipation and reducing the potential for arcing and sparking, a larger conduit size helps to create a safer working environment. Electricians working in classified locations must be aware of this requirement and adhere to all applicable codes and standards. The importance of adhering to NEC 502.100 cannot be overstated. Non-compliance can lead to dangerous situations, including explosions, fires, and electrical shocks. In addition to the direct safety risks, non-compliance can also result in fines, penalties, and legal liabilities. Electrical inspectors play a crucial role in ensuring compliance with the NEC. They are responsible for inspecting electrical installations to verify that they meet all applicable code requirements. If an inspector finds that a conduit is undersized in a classified location, they will typically issue a notice of violation and require the contractor to correct the deficiency. It is important to work closely with electrical inspectors to ensure that all electrical installations are safe and code compliant. Another key aspect of this requirement is proper planning and design. Electrical engineers and designers must carefully consider the conduit sizing requirements when designing electrical systems for classified locations. They must accurately calculate the number and size of conductors that will be installed in each conduit, and they must select conduit sizes that meet the 20% increase requirement. It is also important to consider the ambient temperature and other environmental factors that may affect the heat dissipation of the conductors. In some cases, it may be necessary to use larger conduits or direct the ampacity of the conductors to ensure that the temperature limits are not exceeded. Communication and coordination between the electrical designer, the electrical contractor, and the electrical inspector are essential for ensuring a successful and safe installation. All parties must be aware of the conduit sizing requirements and work together to ensure that they are properly implemented. Furthermore, it is essential to keep up to date with the latest revisions and interpretations of the NEC. The NEC is updated every 3 years, and new requirements and interpretations are constantly being added. Electricians, engineers, and inspectors must stay informed of these changes to ensure that they are following the most current and accurate information. Continuing education courses, industry publications, and online resources are all valuable tools for staying up to date with the NEC. Additionally, participating in industry events and networking with other professionals can help to share knowledge and best practices. By investing in education and training, electrical professionals can enhance their skills and knowledge and improve the safety and reliability of electrical systems in classified locations. The NEC provides specific tables and guidelines for calculating conduit fill, which is the percentage of the conduit's cross-sectional area that is occupied by the conductors. These tables take into account the size and number of conductors, as well as the type of conduit being used. It is important to consult these tables carefully when determining the appropriate conduit size. In addition to the conduit fill requirements, the NEC also specifies minimum bending radii for conduits. These requirements are designed to prevent damage to the conductors and ensure that they can be easily pulled through the conduit. The bending radius must be large enough to avoid kinking or crushing the conduit, which can restrict the flow of current and create a fire hazard. When bending conduit, it is important to use appropriate bending tools and techniques. Manual conduit benders, hydraulic benders, and power benders are all available for bending different sizes and types of conduit. It is essential to follow the manufacturer's instructions when using these tools to ensure that the bends are properly made. After the conduit is installed, it is important to inspect it carefully for any damage or defects. Check for cracks, dents, or other signs of damage that could compromise the integrity of the conduit. Also, make sure that all connections are tight and secure. Loose connections can create a fire hazard and should be corrected immediately. When pulling conductors through the conduit, it is important to use a lubricant to reduce friction. This will make it easier to pull the conductors and prevent damage to the insulation. Use a lubricant that is specifically designed for electrical conductors. Avoid using petroleum-based lubricants as they can damage the insulation. After the conductors are pulled, it is important to properly terminate them at the electrical equipment. Use appropriate connectors and terminals to ensure a secure and reliable connection. Make sure that all connections are tight and that the conductors are properly insulated. Finally, it is important to properly label all conduits and conductors. This will make it easier to identify the circuits and troubleshoot any problems in the future. Use labels that are durable and resistant to fading or damage. In conclusion, the 2020 National Electrical Code's updated requirements for conduit sizing in classified locations underscore a critical focus on safety within hazardous environments. Specifically, NEC 502.100 EO mandates a 20% increase in the internal cross-sectional area of raceways containing 4 or more current-carrying conductors in Class 1, Division 1 and 2 locations. This enhancement directly addresses the elevated risks of fire and explosion inherent in these areas, primarily by facilitating superior heat dissipation. By allowing for greater airflow and reducing the concentration of heat generated by multiple conductors, the risk of insulation failure, arcing, and subsequent ignition of flammable substances is significantly minimized. Adherence to these guidelines necessitates a meticulous approach to design, material selection, and installation. Engineers and contractors must accurately assess conductor loads, select appropriate conduit types, and employ installation techniques that preserve the integrity of the system. Furthermore, continuous education and collaboration with inspection authorities are vital for ensuring compliance with the evolving standards of the NEC. This commitment to safety not only protects personnel and property, but also upholds the highest standards of electrical practice.